Let me permit to introduce you my great friend, Professor Ruggero Maria Santilli, who, first of all, is a great person and a great friend of mine. I'm honored by this friendship with Professor Santilli. But Professor Ruggero Santilli is also a very great scientist who obtained lots of results, who made lots of discoveries in various field of science, and who obtained various awards in various fields. I would like to remember here physical discovery by Professor Santilli, chemical discoveries by Professor Santilli, and of course, as this is a conference of mathematics discoveries of Professor Santilli. In fact, the title of his lecture will be the novel mathematics which underlies the atomic mechanics, which also in turn will be the object of symposium number 50. To finish, before leaving the word to Professor Santilli, I would like to emphasize that in order to honor this conference, Professor Santilli will dress during his lecture and during all the conference the award of the Knight of Sant'Agata. Ruggero, can you show the medal of Professor Santilli is Knight of Sant'Agata. This is an award that obtained last year in San Marino. Okay, thank you very much.
It was granted to all of It was granted in representation of all mathematicians, theoreticians, and experimentalists who work on hadronic mechanics. Yeah. Okay, seems to be. Okay, if we can lower the light, please. Okay, I would like to thank Professor Siemens and Mrs. Rallis and all the organizers for this magnificent meeting. It's always very exciting to be in this group. I would like to dedicate my presentation to the late Professor Gregorio Sagas, the former chairman of the Department of Mathematics of Aristotle University in Thessaloniki. Yes, indeed. A really great mathematician, because he was interested in novelty, in fundamental novelty in mathematics, which is a rarity in mathematical circles, to my knowledge. Also in recollection of this book that he wrote 20 years ago, which is at the foundation of what I have to say now, which is still valid, the foundation, mathematical foundation, the Santilli isotheory. Very well, I have to, my task is rather difficult. I've been asked to give you a review for mathematician and physicist of hadronic mechanics. This is quite a task to do it in 55 minutes, because hadronic mechanics is a covering of quantum mechanics that after over 50 years of research has reached quite some diversification. It's made of layers. The first layer is the different layers is to describe matter in condition of increasing complexity, therefore demanding mathematics of increasing complexity. The first layer is the what we call 20th century layer, namely conventional local differential geometry and topology and differential calculus and so on, conventional theory, quantum mechanics and so on. They are excellent for the description of point particle. We're talking about local differential geometry. Point particle and electromagnetic waves propagating in empty space. They're fantastic. There's nothing to add. But as we would see, nature cannot be reduced to points. So the second layer is the description of extended, therefore non-spherical, therefore deformable particles, and electromagnetic waves moving within a physical medium. At that point, everything blows. The system becomes variational, non-self-adjoint from a mathematical viewpoint. This is Helmholtz. Don't even dream about Lagrangian, Hamiltonian, this type of things. Hilbert spaces, forget about it. So we had to develop new mathematics to treat it. But this turned out, both levels turned out to be quickly insufficient to represent nature. Nature is structurally irreversible. As physicists, we have to recognize that all our when we are born and die, this is irreversibility. And so therefore, all those theories, they have no arrow of time. Einstein's special relativity has no arrow of time. Hilbert space has no arrow of time. So anybody who thinks they can quantitatively represent irreversibility, I think that we will disagree sharply. So we have to develop yet another mathematics with an arrow of time embedded in the most fundamental part, in the unit and the multiplicative unit, of course, of a field of characteristic zero, and related multiplication. All this turned out to be basically insufficient to represent the biological structure, that the complexity is beyond our imagination, and we had to go to what not multidimensional. Our group is not interested in multidimensional. Our knowledge is three-dimensional, but multi-valued. Each axis can have 10 to the 30 order component values. So in this way, we start to initiate what will require 1 millennium in my knowledge to understand the code of the DNA. It's a complexity beyond our imagination. But at least we move away from the numbers that are 3,000 or 4,000 years old. From an algebraic viewpoint, this is Lie algebra, this is Lie isotopic algebra, this is Lie admissible and Jordan admissible, and this multi-valued Lie admissible and Jordan admissible. Incidentally, hadronic mechanics realizes the dream of Jordan that this algebra will one day see physical application. There were none, zero in quantum mechanics. There in hadronic mechanics, yes. And the Jordan algebra as a component of the structure is necessary to represent irreversibility. So Jordan algebra emerged as a very, very fundamental mathematical tool. The number, to understand my difficulty, ladies and gentlemen, I'm talking about I'm told, 30,000 pages of published research. The birth of hadronic mechanics must be traced to 1947, a paper by Albert in which he only defined what is the Lie admissible and Jordan admissible algebra. He gave us an example, flexible algebra, but they do not admit Lie algebra in their classification, so they were completely ignored by physicists. There are so many colleagues. I only want to remember here some of the colleagues who are here. They are the founder, Professor Ingazin, is the founder of hadronic mechanics. Has to be noted, he has fundamental, important contribution in mathematics, physics, and chemistry. Professor Animalou, and also has made some absolutely crucial, we will review, and Professor Vojuklis. Professor Vojuklis, where are you? Professor Vojuklis is at the top of the pyramid, because he's a mathematician from Xanthi, and he is the expert on multi-valued formulation of Lie theory. And of course, this is at the very, very top of the pyramid. What we do in physics at the very, very bottom of the pyramid, we look at Professor Vojuklis up there. So thank you for being with us. I don't have the honor, but notice McCrimmon here, because McCrimmon was an expert in Jordan algebra, and all his work now is pertinent for quantum mechanics. Ladies and gentlemen, I don't have the time to dwell into. I want to, however, indicate that hadronic mechanics has reached sufficient, is now verified, experiment in all. Can please shut off the telephone, please? Hadronic mechanics has now experimental verification in all branches of science and all the way to biology, and as predicted, has allowed new industry, new technology that are inconceivable with the mathematics of quantum mechanics and so on. As a result of this, we have reached financial independence. We have funds, our foundation has funds for research to support research as well as graduate students. I will flash a few possibility for you while we go on. I am distracted by this and then I stop. You have to remove the phone, please. Please disconnect the phone, otherwise my mind stops and I cannot concentrate. Okay, let's get going on the first level. What is the mathematics that we use to represent antimatter? Well, let me go back 50 years. I was studying a graduate study at the University of Torino, and I was interested in seeing whether this galaxy here, was made up of matter or of antimatter. This is 50 years ago. Well, I immediately discovered that everything I was studying, everything, Newton's equation, Galilei relativity, Einstein's special relativity, Einstein's general relativity, they were completely useless for my problem. Why so? Because of a very obvious reason. This galaxy is isolated. I have to assume it is neutral. All all the 20th century theory and mathematics, in the underlying applied mathematics, they only use the charge for conjugation. Once you have a neutral antimatter body, you're dead on the water. Now, as a result of this, the general feeling in science has been that since Einstein special relativity in general do not predict antimatter does not exist. Ladies and gentlemen, I have to voice as a scientist a very, very strong word of caution, because first of all, because we had the result of this has been one of the biggest scientific imbalances in the history of science. Matter studied at all possible level, antimatter only at the level second quantization. Ladies and gentlemen, this is unacceptable. There is democracy in nature, not in our society, but in nature for sure. Also, our Earth has been devastated in the past by antimatter asteroids. I quote only one of many here, the Tunguska in Siberia, 1908. That was the equivalent of 1,000 atomic bombs, left no debris whatsoever. At the epicenter, there were even 3 standing up, scorched, but standing up. Now here they say the dark side of science said, oh no, Ruggero, this was a comet made of water, the water evaporated. Ladies and gentlemen, the safety of our planet is at stake. Do not be blinded and by this type of the entire Earth atmosphere, for 2 days remained excited to such a level that in Sydney, Australia, 2 days later they were reading newspaper in the middle of the night with no artificial light. This enormous excitation of Earth atmosphere has only one scientific interpretation outside politics. That was indeed an antimatter asteroid, and there have been several. But what was the problem? Here, that's why we are at this meeting. Now you start to see why. The problem was purely mathematical. Purely mathematical. Physics is a tiny, puny little corner. Why so? Because basically, to study that galaxy, I needed, as an antimatter galaxy, I needed a mathematics that was completely anti-isomorphic to the mathematics that I had studied. Everything, sinus, cosinus, differential, everything had to be anti-isomorphic. That mathematics did not exist. I looked everywhere. Finally, when I was a member of the Department of Mathematics at Harvard University in the late 70s, I decided, I checked everywhere. I consulted all my colleagues there and throughout America and Europe. That mathematics I needed to do the conjugation for neutral. Conjugation for neutral matter to antimatter. If you add the charge, it's irrelevant. I will not even mention because it's trivial. Did not exist. So I have to say, okay, it's got to be proposed. At least let me propose one. And I propose one solution. Of course, I hope that some of you can propose an alternative solution. This is not necessarily the only one. And this is the mathematics that I propose. One based on the assumption of the number -1 as the fundamental left and right unit at each and every level you can think of, from number all the way to topology. Now, in reality, it's a little bit more complicated than that. The map from matter to antimatter that we use is called isodual. Dual because of the conjugation, and iso in honor of the mathematics of the 20th century, in the Greek sense, isos topos. So we do not propose new axiom. No, just a conjugation that allows us to do. And also this in reality anti-Hermitian, because the charge conjugation is anti-Hermitian indeed. Well, there is the main point. Once you see that this is an anti-Hermitian conjugation, then the construction of what is called today Santilli isodual mathematics is elementary, at least in this version. You will see a much more complicated version very soon. Why so? Because remember, you map the unit. Remember, this is the multiplicative unit of field of characteristic 0. So since it is the multiplicative unit, you don't want to do a minestrone. You have also to map the multiplication. Once you map the multiplication, the important point that you have to remember is that you will see sandwiched in the transformed element of your ring or whatever, the inverse of the iso unit. View of this, then -1 is trivially left and right unit at all levels. Now I have a word of caution with respect to the physicists. When physicists are exposed to this mathematics and its related, they have the following comment, usually due to a lack of sufficient technical fundamental knowledge. Basically, this mathematics implies everything is conjugated. So it implies that antimatter moves backward in time, minus the time. Antimatter has negative energy, etc., etc. Once physicists, they hear that, they say, Ruggero, but you know that Dirac proved in 1930 that negative energy is not physical. Well, this is due to lack of knowledge in the field, as well lack of general perception that there is no democracy between matter and antimatter. This statement that negative energy are inconsistent is exactly the same under this democracy to the statement that our energy, which are positive, are referred to a negative unit, which is nonsense. And that's exactly the nonsense that they do. The isomathematics requires the map of the totality of quantities. You miss one, and you have unseen inconsistency. So therefore, not only you map the time and the energy, but you have to map the related unit. So negative time and negative energy, they evolve according to negative unit. Therefore, they are as causal as ours. Anyhow, after that, we reach a major stumbling block. We immediately saw that we could build an isodual mathematics sufficiently conjugated to start working and playing with antimatter. But we reach that's why I'm here. The first major stumbling block. I am a physicist. Being a physicist means that I have to produce numbers. I need mathematics to produce numbers that have to be verified with experiment. Those numbers, to have a consistent physical theory, must verify the axiom of a numeric field. I changed the sign of the unit. So I was lost for years. Finally, I was in Dubna. I was a guest at the Joint Institute in Dubna, and I had the courage to. The delay was due to my veneration, my devotion to Gauss and Cayley, the classification, the known classification of numbers, real, complex, and quaternion over a field of characteristic zero again. So my devotion prevented me from looking at that classification. Finally, I had the courage, and it turned out that the abstract axiom of a field absolutely do not require that the unit be 1. It can well be minus 1, provided it is the multiplicative unit, provided you adopt an associative but corresponding multiplication. In this case, you easily construct what are called today isofields. They are obviously anti-isomorphic to ordinary fields. That's exactly what we are looking for. And this led to what are called today Santilli isodual, real isodual complex and isodual quaternion. After achieving the numbers, then the isomathematics virtually exploded in physics literature. At the level of mathematics, at this moment, talking about early 90s, there was virtually no interest that I know. Later it came very strong. So this functional analysis and of course Lie algebra and whatever, and Euclidean space, Minkowski space. I don't have to spend much time. It's very easy. You apply this anti-Hermitian map to the totality of the quantity, to the metric, the product, the unit. If you are systematic in applying the map to all, you will reach a consistent structure we called isodual spaces. But then we are talking about the middle of the 90s, we reach another stumbling block. That was motivated. This is the second reason why I am here. And I think it's important to know my experience, not only to physicists, but also to mathematicians. The problem was the following. Not only we have to produce numbers that we have to verify with experiment. It's not enough. We have to produce numbers. We need a theory that predicts the same numbers under the same conditions at different times. If a theory predicts different numbers under the same condition but at different time, I'm not even interested in looking at. This is essentially a question of invariance. The invariance here was the isodual version of the Poincaré symmetry. We are talking about space-time, conventional space-time under isoduality. And the theory was not invariant under this isodual image of the Poincaré. So therefore, I was afraid that years and years of work had to be trashed. As a physicist, had to be trashed. No value whatsoever unless we met that condition. We'll not surpass the test of time. You can get chairs and prizes, yes, but the test of time, you will not pass it. And so again, I had to have the courage to confront a topic that had been untouched in mathematics for centuries. And that is Newton's Leibniz differential calculus. Is it really final, the way I've been taught in graduate schools? The answer was no. The moment I had that courage, immediately came out that the differential calculus has a hidden symmetry. It's invariant under isoduality, and we call it iso-self-dual. It's hidden in the very, very structure, because you have to conjugate the local variable differentiation. You have to conjugate the operation, and this is an invariant. This seems to be very mathematically so trivial that I have no words to say. This is what I discovered. But if the universe is made up 50% of matter and 50% of antimatter, ladies and gentlemen, iso-self-duality is then the most fundamental symmetry of nature, because it's the symmetry of the universe. And the consequences are far non-trivial. The total energy of the universe is zero. The total time of the universe is zero. Talk about the age of the universe. It's nonsense. And the incidental imaginary number has indeed this Dirac equation verifies this, many other structures verify this equation. Finally after, and only after completing the mathematics with the conjugation of the differential calculus, Newton calculus, then physics exploded very, very quickly. First of all, we were able to achieve what is the first, in my knowledge, if any of you has another equation, please, I beg you, let me know. We reached the Newton's equation for neutral antiparticle. Newton's equation for neutral antiparticle. And then we approached, we addressed the issue of the universality of Newtonian gravitation, which claimed to be universal. For me as a student at that time, I said, no way. Where is antimatter? Where is light? So, but in this way, we were able, with isodual mathematics, we were able to include in the Newtonian gravitation the antimatter, and we extended the attraction to light, both emitted by matter and the antimatter, by using the energy of light rather than energy is a source of gravitational field, as Einstein says anyhow. So and then you can do the same results by the isodual version of the Riemannian geometry. Allow me the first geometric treatment consistent from A to Z, as far as I know, axiomatically and otherwise, of the gravitational field of an antimatter body. Very well, then Lagrangian, Hamiltonian, quantum mechanics is all trivial. The important point is that the operator level isodual math coincides with charge conjugation. Coincides, there's no equivalent. So therefore, this what I presented to you now, this mathematics and the related theory represents the totality, are verified by the totality of knowledge, experimental knowledge. We have an antimatter from Newton to second quantization to CERN accelerator, whatever it is verified. At this point the question is, is there any new prediction? Yes. Despite the triviality of the mathematics, this should illustrate the enormous importance of mathematics in physics. I have no words to express it, because I've seen this, you know, the emotion of seeing the implication of even simple mathematics have enormous physical implication. The first implication is that the dream of mankind, which is anti-gravity, namely gravitational repulsion between matter and antimatter, or if you want, a negative curvature tensor, if you want, is unavoidable from Newtonian to second quantization. Our foundation hopes to fund an experiment measuring the gravity of the process, and maybe in a year or so we will report the result. But there are other non-trivial. You see, light has no charge. So this theory has been developed for neutral particles, neutral antimatter particles, applies for light. And it turns out that light emitted from antimatter is physically different than light emitted by matter, not only because the energy becomes negative on a negative unit, but also because it becomes repelled by a gravitational field of matter. Also the refraction, as a result of this refraction, the refraction is unknown. I only list here the possibility of a light emitted by antimatter passing through the transparent matter body. We do not know which is those three. See, similarly, if you ask me, can can we see an antimatter star far away? I do not even know the telescope that we can use because we missed fundamental experimental information due to the obscurantism on antimatter in the 20th century. So so the point of caution, can we see an antimatter asteroid with the sunlight? This is assumed that this is antimatter and we have the light is from our sun, so it's a matter light. Can we see it? The answer I do not know. I need some basic new experiments. So let me go back 50 years. So can I answer whether this galaxy is made up of matter and antimatter? Ladies and gentlemen, if we trash out arrogance, which is the antithesis of science, the answer is one, and only one. I do not know. I cannot make a scientific statement beyond saying I do not know. We have to do basic experiments to keep going. Let me go back to the second level because there is a long journey that I have reviewed. This is the very, very beginning. Still point antiparticle. And I have this reference I can only quote. It's available in PDF download for the second level. Here is a view of what Galileo Galilei saw first with his telescopio, namely the Jovian system. But I projected this to remind colleagues of a fundamental mathematical and physical point. Jupiter and all these planets and all the satellites are approximated as massive points by Newton, Galileo, and Einstein. And because if they try anything different, the mathematics is unable to go beyond the point. The local differential topology and the differential calculus, you cannot do it. You cannot represent the extended object. So what we are studying here, this is what we are studying. We are studying the structure of Jupiter as an extended body that is isolated from the rest of the world, therefore does verify the conventional 10 Galilean conservation law, energy, etc., etc. But this is what disturbs most physics colleagues. Inside you see vortices with a locally varying angular momentum. And when they see this, of course, because this implied departure from everything you know in 20th century, mathematically and physically. And at an operator viewpoint, there's the sun. A word of caution here, because you hear everybody, even at the highest level of the physics community, Ruggero is studying a problem that does not exist. Because when a proton is inside the sun, quantum mechanics applies. Ladies and gentlemen, I have to voice some caution here, because this is scientific obscurantism. The proton is an extremely large object at the particle level, very large, 1 Fermi in diameter, and it is hyperdense. So when this enormous object is inside a star, my God, you reduce everything to variation of potential forces, linear, local, Hamiltonian. Ladies and gentlemen, if it is presented as a crude approximation, should be respected. But it is presented as a truth. It's political, and you'll never get me on that point. But now another point I want to bring to attention of applied mathematician here, and that's the so-called no-reduction theorem. When orthodox colleagues see this the study that we do, say, no, it doesn't exist. Because you see, this is a satellite during re-entry. You can decompose all decompose that satellite to the elementary constituents, and you recover everything. Ladies and gentlemen, a word of caution, because you may lose your credibility, because there are now no reduction theorem proven. This one was proven 50 years ago, but now they've been republished all over the world. The people who ignore them, they ignore their perp. You don't need a PhD in mathematics to see that the non-conservative, technically variation of the non-self-adjoint system, cannot be consistently reduced to a set of finite number of particles, all in conservative condition. This is a dream. Mathematically, it's total nonsense, and the vice versa too. What does it mean? It means that this non-conservation that we see at the macroscopic level originates at the most ultimate possible level of nature, and that is, and it is due to the fact that, sure, there are point particles. This for instance, the valence electron pair. Sure, of course, the valence is a point charge. This is beyond discussion. But the point is that there exists in nature no point-like wave packet. There are no point-like wave packet. So what you see here is the symbol of the Institute. It's also the symbol of our meeting. Namely, what you see here is a deep penetration of wave overlapping. And you see an area, a volume you cannot reduce to a finite number of isolated points. You look deeper into this, and this implies non-interaction, non-linear at the highest level in the derivative of the wave function, non-linear and non-local integral, and certainly non-Hamiltonian, namely not describable from the Hamiltonian. In any case, there must be some new force in the valence, because look at the strength. Look at the strength. This is the strength of the valence. Think. Don't stay at what is written in the books. Use your brain and think and meditate on. Look at the strength. What you have, this is due to the valence coupling. Ladies and gentlemen, I've been taught from first year graduate school, two identical electrons repel each other according to quantum mechanics because they have the same charge. So there is something missing here. Please do not mention the screened Coulomb potential, because we enter into, I will not recommend for your own reputation. The screening of Coulomb implies the loss of quantum. Screening of Coulomb, the violation of Galilean relativity. The imprimitivity theorem is gone. The very use of word quantum is debatable. The number of, in any case, you screen with a function fitted from the data. So please, we are dedicating an entire day to the study of a hadronic chemistry. I cannot say anything more. Anybody who's interested in which we do achieve indeed an attractive force, a real attractive force between two identical electrons by using this new non interaction. Let me move quickly. Now the question was, we knew this 50 years ago. The question was mathematics. Mathematics is the problem. Mathematics is the problem. How do we represent those non interaction? Is not enough. They have to be represented in an invariant way, because if we don't have an inner word, the Coulomb interaction are invariant respect to Galilean symmetry over time, unless we have the same thing, same invariance for those non forces. I would have been wasting my time. So we spend a decade in looking because those forces you can represent with anything you want except the Hamiltonian or the Lagrange. So the question was, which was the alternative? As we're looking for years, the only alternative we have located until now, and I solicit other alternative with great appreciation, is to represent those non interaction with the unit, with an integral differential realization of the basic unit of the mathematics. Physics is a tiny little corner. And why the unit? Because the unit is the fundamental invariant of any theory. I could find no other object in mathematics that will guarantee me invariance as the unit. It's now called the Santilli iso-unit. Here's one of the many realizations. Here you can see those three elements represents the non-spherical, deformable body. The number 4 represents the density or the index of refraction. This will represent the most general possible integral differential interaction that you can think of. Now this isomathematics, they call also Santilli isomathematics, has two realizations, one called regular and the other irregular. From a mathematical viewpoint, I believe, at least from my interest, the irregular version is the most interesting. But at this level, I can only stay at the regular level. At the regular level, the construction of isomathematics is elementary, because basically it is a non-unitary at the operator level or non-canonical at the classical level image of conventional applied mathematics from A to Z. So you select the most general conceivable non-unitary transform under the sole assumption that it's positive definite. Keep in mind that the functional dependence is totally arbitrary and totally unrestricted. Of course, you need smoothness condition, etc. But except for that, so once you select this most general, you submit the trivial unit, the Planck constant, if you want, or the number 1. To this non-unit, you get the iso unit. Then it must remember again the multiplicative unit must submit the product. So the product again, you end up with the sandwiching in between the transformed element of the inverse. This is called isoproduct because verify the axiom of associative product, and therefore then whatever you take for unit is indeed left and right unit. Once you see this, the construction of the physics, but you need all the mathematics beyond, then it's trivial. Lie algebra, this was Professor Gregorio Zagas studied, because I did, as you will show in a moment, the lifting of Lie theories, as you will see, is just straightforward. And of course the lifting of Lie transformation groups, lifting of Schrödinger equation, canonical map. Look at here. Assume that W is bigger than 1. Assume that in this canonical series W is bigger than 1. So this is divergent intentionally. Gentlemen, this image is strongly convergent. We have no divergence in quantum mechanics. Trivially. Why? Because the absolute value, the unit has a very large value. So its inverse, which is T, called the isotopic element, is always very small value, so it's smaller than W. This converges very strongly. Now again, the stumbling block, okay, we have represented beautifully, because look at this. Look at this. The Schrödinger equation, we embedded all the nonlinear term in the isotopic element. The Hamiltonian was the conventional linear, so we transform extremely complex nonlinear interaction into something much easier to handle. But I am a physicist, so I need numbers, so I have to confront the issue of the number. And I had to go back to the historical classification of number, and it turned out again that the abstract axiom of the field do not require that the basic unit is either the number +1 or the number -1. But it can be an arbitrary, completely arbitrary integral differential operator if you want, and provided you accordingly modify the multiplicative unit. Everything else stays, and you verify all the axioms. I don't have the time to be technical, but I want to word of caution to fellow mathematicians, because I see statements in pure mathematics, especially in number theory, in which I have to express some no criticism. I beg you. This is where among friends to help each other. Just I want to let you know for your own protection. I see statement, for instance, that the number 3 is prime. Ladies and gentlemen, no, it's not a convincing statement to me. Let me elaborate why. Suppose you wake up one day, as I did, and try to use the number 1 as the basic unit. I want to use the number 1/3 as the basic unit of my studies. Fine. Then you apply the isofield, and you see 3 multiplied by 2 is 2, no longer 6. And the number 4 is prime. Then the number 4 is prime under the full verification of the axiom of a numeric field. Therefore, the mathematically correct statement, the number 3 is prime, has to be completed under the assumption, because it's the assumption of the author, I don't like it, I change, under the assumption that the number 1 is the basic unit of the field, then number 3 is prime. Without that completion, I have objection. There have been many papers. There is a book on isonumber, Santilli isonumber by a Chinese mathematician. I strongly recommend you to read it. After I identified the numbers that are called now Santilli isoreal, isocomplex, and isoquaternionic numbers, Iso-octonian, we know them, but they don't verify the axiom of a field. So we lifted everything, not only functional analysis. Professor Arrigazini is here, has done fantastic contribution, Kadishvili, many others. And then we lifted vector spaces, we lifted the Minkowski spaces, which we'll see in a moment, more details. And this was the job that I attracted attention of Gregorius. Namely, in 1978, when I was at the Department of Mathematics, I lifted isotopically, means under the same act, all the main structure of Lie theory. Namely, first I lifted the universal enveloping associative algebra, and ending up with an infinite series of isomonomial, ordered isomonomial, that allow me to identify the exponentiation in this mathematics. And what I saw an integral differential operator T in the exponent of this expression. When I saw that, nobody stopped me. Nobody stopped me, because this means the transition from Lie theory, which characterizes linear, local, and Hamiltonian system, to a covering theory using the same axiom but allowing to treatment non-linear, non-local, and non-Hamiltonian system. And of course, I lifted the Lie algebra. Oh, here, careful, I quote here the structure function. They emerge only in the irregular realization of the Lie-Santilli isoalgebra. If you have a regular, this necessarily has to be a constant for various reasons. And then the Lie group and the Baker-Zahn composition and so on. That we have funds from the foundation for mathematicians to study the representation theory of this image of the Lie algebra, because it has now many direct, very intriguing physical application. You cannot even impossible with conventional Lie theory. And what is the secret of the success? After you look in the details, we reconstruct linearity, locality, and canonicity in what we call isospaces over isofield, to such an extent that now the Lie-Santilli isotheory can be, we have done this, we have picked up a book, a conventional book by leading mathematician, Lie-Santilli isotheory, without any change in any symbol. There is no need to change any symbol. We're just interpreting the basic unit, the multiplication, association. Just by subjecting to a broader realization, you are able to treat non-linear, non-local, and non-Hamiltonian systems. I insist on the point that there is no need to change the symbol, because at the very, very essence of abstract unity, at the abstract level, that we have preserved Lie algebra. Okay, after all this, we reach another major stumbling block, and that's why I'm here. That's the third reason why I'm here. Namely, we had no invariance. We had now the numbers, we had beautiful formulation. At that moment, the application of hadronic mechanics, I didn't even start to do application because I knew it would be inconsistent. Why? Because we need a theorem that will predict the same numerical value under the same condition at different times. And that would cause, and so we, in the meantime, we had lifted isotopically everything we possibly could. And so we were stuck for years and years. Finally, I had the courage again to inspect Newton, Leibniz, the ordinary differential calculus, and what it turned out that contrary to what I was told in mathematics, the highest level in mathematics, the differential calculus is indeed dependent on the unit of the base field. Trivially, if the unit of the base field does not depend on the variable of differentiation, of course, then there is no dependence. But if the unit of the base field depends on the variable of differentiation, ladies and gentlemen, then the ordinary differential calculus has no sense. First of all, because the variable has to be an isovariable. Remember, for consistency, you have to lift everything. You miss one, and you have insidious inconsistent. They appear to be consistent. In reality, they do lack of knowledge or lack of complete. So the variable has to be lifted. The moment you lift the variable, immediately you see inside of R you have an integral differential, the most general possible object you can think of in mathematics. And when you look at the differential of that most general possible object, you see it's not the ordinary differential. You have to lift. However, you see the differential. So you see the isounit as part of the variable to become an isoscalar. But outside you see the inverse. So of course when the isounit is independent from the local variable, then you recover ordinary differential calculus. And that's the same Once and again, after and only after we had completed our mathematical homework, the physical application came in a flash. Let me flash you one of them. First of all, we were able to extend Newton's equation to particle of arbitrary dimension. I should say, generally non spherical, because there is a topological point to be clarified. We extend Newton's equation to particles that are generally non spherical, but ellipsoidal, but deformable under the most general possible interaction. And then consequently, we extended Newton's gravitation to those extended non-spherical objects. And this was done at this memoir of mine at Rendiconti Circolo Matematico Palermo, 1996. Ladies and gentlemen, this is a very little equation, but the implications are very serious, particularly in geometry. It implies that gravitation is directionally dependent. The moment you represent an object a ball in its actual shape and actual geometry, you cannot use Riemannian geometry. Riemannian geometry becomes insufficient. In particular, it becomes that the gravitational field of Earth is necessarily anisotropic, because contrary to what Riemann predicts. First of all, because the Earth is not perfectly spherical, and secondly, because the Earth spins, so you have a preferred direction of space. It doesn't exist in Riemann. But it exists in the iso-Riemann, very, very numerically represented. Mathematically, maturity in this was achieved by thanks of a major contribution by Professor Ganformina and Nunes from Spain, who formulated what I consider one of the biggest mathematical contributions of the 20th century, namely the isotopology. It's the first topology that allowed the representation of extended object, which is necessary to enter into the second millennium. I have a comment for a constructive comment for the preceding speaker. I don't know if he's still here, but you should look at this equation here, the way it is written here. I dedicated 2 volumes when I was at the Department of Mathematics at Harvard in 1978. I dedicated 2 volumes to the inverse problem that were published by Springer-Belag. What you see here on the right-hand side is a non-self-variation or non-self-adjoint, the sense of Helmholtz, differential equations, and on the left what you see identically, there is no equivalence, identical reduction to a self-adjoint system. What does this mean? It means this: there is a little theorem proven by I believe Jerzy Kadishvili, essentially stated that any nonlinear and variational non-self-adjoint, mean dissipative, such as the preceding equation, any nonlinear and variational non-self-adjoint equation defined on ordinary space over an ordinary field, given such under certain smoothness condition, there always exists an infinite number of isospaces over the corresponding isofield under which the dissipative equation can be identically rewritten in a form that verifies linearity on the isospace. We call it isolinearity. So basically, the trick is elementary. You embed all the nonlinearity in the ISO unit. You construct the mathematics so to have that ISO unit all level. You recover an identical, careful, local coordinates don't change, an identical equation. Now we have funds among various funds that we have funds for mathematicians interested to see whether this infinite number, the solution of this infinite number of possible linear equation on isospace of our isospace are also solutions of the nonlinear differential equation. Because if this is the case, then the complexity of the nonlinearity becomes a recollection of the past century. I also have, I see some new mathematician here, and I have a comment. Allow me, don't feel offended. I am much older than you. My recommendation is the following. We are at the beginning of the third millennium. And you have an alternative. Either you keep working on mathematics that belongs now to the past millennium, or in which case, very likely, you'll die an unknown. Let's be honest. It's something that you have to have the courage to tell yourself. However, if you study fundamentally new mathematics, you have a serious chance to be remembered as a leader of the dawn of the third millennium, because we need for society to go forward, we need mathematics, but not all the magnificent mathematics of the 20th century. And now we have reached the limit of what can be done, and it's very difficult to do anything else. Now, one of the applications of the isomathematics, and particularly isotopic theory, has allowed the solution of the so-called historical Lorenz problem, namely the invariance of all possible local speed of light. We are talking about 1890, talking about Lorenz time. Lorenz resolved the problem for a constant c, and the solution is provided by the invariance of this element, in which, of course, you see the local variation here. This is what we call iso-Minkowski space. I will go to it in a moment. Be careful in reducing light propagating in water or in a physical medium to photons. It has been discredited in many refereed papers, and we can discuss it during, I think it will be discussed tomorrow in all details if you are interested. The solution, I don't have the time to dwell on it, but I want to flash at least something I want to flash. Allow allow me a very disturbing gesture for orthodox physicists. And this is the very disturbing sense. Very disturbing. Try to do this at my former colleague at MIT, Harvard. You see the nostril vibrating. Why so? Because this is visual evidence that quantum mechanics and Einstein's special relativity have limitation. Because this is deformation theory. It is known. Those theories are incompatible with the deformation theory. And don't forget the no-reduction theorem. You cannot reduce this to magnificent cozy particle and you reconstruct it. No, you will never reconstruct the deformation. This has been published in there. So no, this is essentially, you need new mathematics. It's the mathematics of the 20th century, magnificent, non historical contribution, but has limitation. And besides, there are better mathematics. This is one. For instance, we call it iso-rotational symmetry. It gives you the invariance of all arbitrary deformation of the sphere. So why to keep using the old one when there is a covering? And the same for the Lorenz transformation. Now we have coverings. Those are, however, look at this. Those are isotopic. The axiom are the axiom of Lorenz. But they imply arbitrary speed. The speed is absolutely unrestricted once you do this. We are talking about object in a physical medium. Don't think spaceship in vacuum. You will be out of whack. No, think about a proton inside the star. The speed is, according to this geometrical view, is arbitrary. However, ladies and gentlemen, the axiom of Einstein's special relativity at the abstract level are presented in their entirety. So claiming a violation of Einstein for arbitrary speed is usually due to lack of knowledge of proper mathematics. And put in a different way, that's the way we honor Einstein. A number of our colleagues, they abuse the name of Einstein by applying their theory the way they were formulated under conditions they never thought of. Einstein, Poincaré never thought of that. So that is abuse of their name. No, we are different. We maintain their axiom to honor those names, and we show that those axioms have a broad realization. And in this case, the conclusion, think in a different way. When you look at the Lorenz transformation, you see C. The value C of 300,000 kilometers per second has been set by mathematicians, not by the Lie theory. So that value C can be arbitrary. Therefore, from that simple remark alone, you can see that arbitrary speeds are compatible with Einstein. It all depends on the mathematics that you use to formulate the Lie theory of the Poincaré symmetry. If you don't know enough mathematics, stay out. Don't make no comment. This is basically my suggestion. And then let's keep going. And let me flash a few experimental verification. Let me recall the monolithic, magnificent construction of the 20th century, mathematically and physically, on the Minkowski space. Once you set this, you set everything. You have the invariance on the Minkowski space, you have Lorenz symmetry, uniquely characterize Einstein axiom. There's nothing you can do. That's it. There is nothing I can say. Now, everything, however, can be lifted. If you lift everything consistently, you maintain the same structural, axiomatic, good structure. But the consequence, this will be the most general possible. We are talking about symmetric system here, as I stated at the beginning, isolated system. But look at this. First of all, the objects are deformable, and then the maximal speed is arbitrary. Arbitrary depends on. In water, is 1/3 of the speed of light in vacuum, and inside the proton we would see it's much higher, and so on. Then you have a variation of frequency without relative motion, variation of frequency without relative motion, gravitational fields that are locally anisotropic and often, those are the axiom. But let me flash you some of the experimental confirmation. This was done also in Dubna many years ago. Enrico Fermi stated that, let me back up for a little bit. One of the insuccesses of quantum mechanics in nuclear physics, this is the best kept secret, they would not say so in graduate school, at least in the USA, but not in our graduate school. We studied this. In our graduate school, we do this because we want to represent physics, not theology. So Enrico Fermi noted, since there was one, already during the Enrico Fermi time, the failure of quantum mechanics, 5 minutes, to represent nuclear magnetic moment was obvious. So he suggested that protons and neutrons can be deformed. slightly. Once you deform slightly, you represent numerically. But admitting a deformation of the proton and neutron means abandoning quantum mechanics. Let me flash other representations, since this is the Bose-Einstein correlation. Those are the variation of frequencies without relative motion between the source and the frequency, which have been verified. We are remeasuring here, hoping that the weather is good, measurements in which the transition from the sun at the zenith to the horizon is a redshift. The entire spectrum shifts, and is exactly the same as for galaxy. Below you see galaxies, and then here you see the spectrum of a special analyzer advantage. Here you see the zenith that moves, and then at the end of the horizon you have about 200 nanometer of this, ladies and gentlemen, implies this redshift occurs without relative motion. It's exactly the same for galaxies. This implies that the universe is not expanding. Technically, it implies that the cosmological redshift does not necessarily imply that the universe is expanding, because there are other alternatives, and they are now fully developed. This is Professor Nims that is now verifying here. He's here with us. This is the equipment that he has here in our room, in which he produces communication. He has electromagnetic waves propagating at a multiple of the speed of light. And anybody interested can see the theory as well as the actual, and see the way it is production. There are communication. Think a moment. This one day will replace the fiber optic, because they will be immensely faster than that. The Professor Kolminsky is with us. He has proven also deviation for rotating system. And Professor René Verrold has this, I consider a fundamental. It's an historical moment in geometry, because it proves what intuitively you can see, that the gravitational field of a neutron star cannot be homogeneous as Riemannian geometry says. This becomes a theology. But he has proved this on Earth, has proved this possible, and so it's the dawn of the third millennium in geometry promoted. This is the case of at CERN, this fight between superluminant and subluminant particles. I just only want to mention that a sad point, that all this fight, as you may know, the article announcing the superluminant, and there was a big fight. Antonio Ereditato, the director of the project, was thrown out by this dark side and they rewrote the paper. Instantly it was published by the Physical Review Letter, instantly, because verifying Einstein has been. But what really makes me a little bit sad, and I will conclude I would like to flash the lead missile, is this, that all this horrendous academic fight in maintaining the Einstein theory, maintaining what they perceive, refers to what? Refers to the presumed validity of Einstein, special relativity, underground. The neutrino propagated underground from CERN to Italy, underground. How can they possibly fight all of this? Show me the invariance of the speed of light underground. Show me how you define special relativity underground. The list is enormous. So this is what's going on, and I have to, as an American citizen, I have to express my serious reservation and sadness, I must say, because this is an episode of organized suppression of scientific democracy in the United States of America. Also, I have to express a point, namely that we all know the financial situation of our countries, not only America, Greece, Italy, all over. There is a slowdown of the economy. This is dangerous. Eventually may lead to upheaval, social, political, and therefore military upheaval. We as scientists, we have a duty. What the duty? We have a duty of promoting a scientific renaissance. Better off promoting a technological renaissance. But you cannot have a technological renaissance that will revamp the economy. We cannot have a technological renaissance without a scientific renaissance. And we cannot have a scientific renaissance without surpassing Einstein and without surpassing the mathematics, the 20th century mathematics. So that's why I have no words unless mathematicians participate in third millennium basically new mathematics. There will be some there may be some dangers. Remember, most of the mathematics I present has been developed by physicists, not because of very special needs. Now we have, thanks God, we have now magnificent mathematicians that are helping us, but if we have new ones. If I have 1 minute, I would like to present the Lie admissible, at least flash it, because it's the most important part of this is a view of the Dirac delta becomes, for an extended particle, here you have a singularity, quantum mechanics. Hadronic mechanics, you cannot have singularity. It's spread over, it's an extended particle. But let me flash, at least flash you the technology has predicted new fuel via submerged electric arc. I cannot do this calculation in submerged arc with quantum mechanics. Come on. How do I calculate the resistance? Come on. Or using applied mathematics? No. I cannot do that. Now let me flash very, very quickly the issue of irreversibility, because I think that's, Mr. Chairman, I really appreciate 1 minute, but everybody's free to go, because this is real essence, real novelties at this level. What I said before is isostopos. Here is genostopos, so it's new. The axioms are new. And here is the issue. This is a scattering, energy scattering at CERN. What you see is, everybody can see, is profoundly irreversible over time. And now keep in mind the no reduction theorem. You cannot reduce this to nice little points that are reversible over time. You have all sorts of inconsistencies. So this required, when I went to Harvard and did this vignette that I presented to my colleague Weinberg, Glashow, and Coleman, I presented this vignette. We say, don't chop off the external term of Lagrange and Hamilton's equation, because that's where the physics is. But of course they want to chop it off because they were, Einstein fellows. So, but however, if you include the external term in Hamilton's equation, you lose an algebra in the bracket of the time evolution. So that was a stumbling block that required a long time. Here is a solution which I proposed in my graduate students. It's my thesis. I understood that the reversibility of 20th century theory is due to this invariance of the Lie product. This is Schrödinger equation is invariant of anti-hermiticity, and that's the time reversal invariant. So I had to break this time reversal invariant, and I presented this 1967 nuovo cimento, the PQ deformation of an algebra which are partly Lie and partly Jordan, as you can see. Everybody has ignored this deformation. Biederer in '86 wrote in a paper in Q deformation. There were tens of thousands of papers. None of them quotes the origination here. I am so happy because they are catastrophically inconsistent. I don't want to be quoted. That's what I want to flash, Mr. Chairman, because I think it's an important point. Now, then I went to Harvard and I formulated the most general conceivable, possible Lie admissible product, combination of Lie isotopic and Jordan isotopic. And the mathematics is bimodular. But however, modular action to the right is inequivalent to the modular action to the left. What I want to indicate, and then I stop, is that this theory at this level turned out to be catastrophically inconsistent because it does not physically, even mathematically, because even you define this theory on a base field. But then the time evolution is non-unitary. So on the time evolution, the basic unit of the basic field is gone. So you lose the basic field on the time evolution. So what type of mathematics can you formulate when the base field is gone under the time evolution? So you have catastrophic mathematical inconsistency in PQ deformation. That's why I want my name associated with that. And then along the physical inconsistency, as graduate students of mine prove that the time evolution of these things shows event preceding the cause, and so on. So now you need this imbalance. For this we have to construct what we call the Gannon mathematics, and we have to invent the law in the product. Pick up a field, set up all the product to the left, still a field. With the same ring, still remains a field, verifies the axiom. And then you set all the products to the right, still a field. So from an ordinary field you can get two, construct two of them. One with product to the right, and one old product order to the left. And we assume product to the right, evolution forward in time, and the other backward in time. And from this we have to construct again, for the third time, the totality of lift, the totality of mathematics, in this, however, in this case, complex, because it's bimodular. And so there is lots of work to be done in mathematics. Our foundation has funds, and we will appreciate any contribution. Thank you. Thank
you. Any questions?
Just one comment. I start with this. I should have been the family. attacking physics all the time.
No, I'm not attacking physics.
Hold on. I mean, physics is essentially experimental science, right? It doesn't have the term mathematics, but it's experimental science. So
Could you please identify yourself, because we are on the film. Could you please tell your name, please? It's important. It's appreciated.
yes, Lorenz.
Thank you.
Sorry.
No, thank you.
I mean, essentially, physics is experimental science.
Yes.
I think it's very dangerous to sort of neglect it and put it into corner.
To put it to?
Into corner, because you mentioned twice during the talk that physics is something that should be put in corner. Right? If I haven't misunderstood. And I really don't understand that attitude.
It's not, no, I think it was my fault, it was not properly put. My point is, I think I said it repeatedly, I am a physicist. Everything I did as a physicist. But I need to develop the mathematics. I had to spend 80% of my time in the mathematics. The idea that the physics is a corner of my time, as far as the effort, but not physics. I am a physicist. Physics for me is so I apologize for not being precise, and thank you for raising the question. It was an important clarification. No, I am a physicist. I want to do physics. I particularly want to do experiments. You will see experiment here during, however, we have new physical problems that unfortunately we were able to handle quantitatively without the mumbo-jumbo assumption of this, assumption of that, and then, no, we don't do that. We have to have quantitatively. We need a new mathematics. It was inevitable. Yeah, in that sense, but however, there's the beauty of both mathematics and physics. Thanks.
I'm also experimental. I'm a nuclear physicist, and I obviously work collaboratively a lot with Santilli since meeting him a couple of years. So I have to say, as an experimental physicist, his physics, his mathematics is revolutionary. And some of the things that the physics have uncovered, obviously in the future lectures, and we've come up with all these dark energy, dark matter, with the missing antimatter, quantum entanglement. So we experimental physicists have come up with these fundamental problems which current physics or current mathematics theory cannot explain. And I, for one, am excited by the new mathematics and the new science that's come out that will help explain all these unknowns that we experimental physicists have come up with. And I, for one, as experimental physicist, am excited by the presentation, and I'll be in one of the symposiums which basically see how in this case, the hadronic mechanics relates to my field in fusion, nuclear fusion. So I, for one, am excited by what Santilli, and hopefully you get a chance when you see all the mathematics applied to present-day physics, trying to explain all these unknowns that we presently have that present science cannot answer. And physics is definitely not in the corner for me. Physics should take the lead.
Thank you, Professor Ying. To clarify the importance that the new mathematics, in this case, is admissible because you need irreversibility. Fusion are irreversible over time. If we include the irreversibility, the new fusion that Professor Ying indicates, and he's an experimentalist, he has verified them. They have no harmful radiation. So we have fusion with no harm there. We don't advertise, and back to your question, for instance, I have to elaborate my comment to the preceding, to the importance of new mathematics to solve for physics. He has a magnificent practical problem, the optimization of that dissipative equation. But you see, by using the new mathematics, you can turn identically that equation in a linear equation on a suitable space. So you simplify the physical problem dramatically. I mean, the gain in new mathematics is for us physicists, it's very, very strong.
My name is Schmeichel. I am a physicist, mathematical physicist, and sociologist, and I have been among the first high-energy physicists.
Could you please identify your name because you are under camera?
Schmeichel.
Thank you.
And I worked in the first high-energy group of theory, and these problems never let me go. So I just can tell you thank you, because I find it of a great advantage that there is some mathematical overview. Yes? I come, by the way, to the same results using Clifford algebra.
Yes.
Using discrete mathematics.
Yes.
You always have to identify the identity.
Yes.
As long as you can do it, you get no proper theory. I also agree with what you say, the universe might have zero energy. I come to the same conclusion. And the time operator can decompose entirely in the quantum level. But I have a very, very important question, because I can see that from your slides. I must ask that. Please say a word to Feynman's quantum electrodynamics.
Yes. Well, first of all, could we invited with acceptance of admission committee? We would love to. Your approach of Clifford algebra, what we are doing, is magnificent. It's because geometry and algebra are the very, very essence of physics. I remember I always in physics. If you have the time and you want to have a presentation of your research, you are much welcome. We are very interested in alternative view.
Presentation after tomorrow.
Well, but you can present it. You can redo it. You can redo it in our. We are 7 days, and there are 7 days seminar course. You are welcome. Back to your question. Yes, this is this is. Let me go back, because this is implies all sort of. Can you lower the light, please? Well, this implies lots of money that mankind is now spent. There are about trillions of money, and I heard a meeting. Steve Weinberg is now organizing in Texas with CERN. They want to build a new collider. They were talking about another trillions of dollars to build a new accelerator. You see, once you admit irreversibility, and you reach a certain, but only have to admit irreversibility. Feynman diagram have no arrow of time. So it's something beyond Feynman, from an algebraic, mathematical, in any way you want. Once you admit, you include irreversibility in this, but you have to go necessarily higher at Lie admits. You have to exit from Lie and at a higher level. Then, and when you reach high density, we are reaching now this Terra energy, we are talking extremely high density interaction region. At that level, Feynman notion of interaction via an exchange particle is impossible. We have proven this thanks to Professor Animalou, collaboration, is here with us with 5 papers presented at our conference in the admissible in Nepal 2011. Then this means that the Higgs boson cannot exist, and not as defined as an exchange particle in a region which is the densest region in the universe. There is no, you can think in a different way. The limit of Feynman, why? Because your question is very, very fundamental for for scientific accountability, the way we spend billions of dollars. Look at the limit, you can look at the limitation of Feynman diagram when you look at the interaction electron-positron. When you look at the interaction electron-positron, you have, Feynman has to put a particle, but that violates the democracy between particle and antiparticle, violates the iso-self duality. So it's not a final, it's a magnificent. Feynman got the Nobel Prize, but you see, the science, in annihilation, cannot occur without an exchange particle. You have all sorts of inconsistencies. It's an irreversible process that does not admit an intermediary particle. After having said so, however, back to your question, quantum electrodynamics for matter at large distance is a fantastic theory, proven experimentally beyond any doubt. The point that however has limits. Unless we identify as scientists and we bring those limits to the attention of our administrator, we keep wasting billions of dollars on something that cannot even be defined. Thank you for asking the question.
Thank you for the answer.
My name is Thomas Rodriguez, and you mentioned my name. I'm a pure mathematician. I'm not a physicist. I'm not an applied mathematician. I don't understand also why Professor Santilli put me in the top.
On the mountain, because you deserve it.
I think I am not an applied mathematician, but we have several papers with Professor Santilli, and he insists that my mathematics are applied, but I don't understand it.
Well, Let me make one comment, please, Mr. Chairman. It's an important point. Thomas, I have to be honest. Remember, when arrogance is trashed out, we have to be honest. I do not understand myself. Your mathematics is the most general possible formulation of Lie theory that you can, human mind can think of, multi-dimensional hyperformulation with a unit that can have 10 to the 30 order elements. This was conceived for biological structure. I am a physicist. The complexity of the biological structure, I have to be 100% with you. I do not know. We know that we get some insight, some basically new insight. The point was this, that the point, I think we should bring it to the attention of mathematicians because they may stimulate, here, this is a seashell. The seashell, the shape of a seashell has been represented many, many times. Fourier, fantastically with 20th century applied mathematics. But Hillert, in biologists in Australia, proved that when you try to apply conventional mathematics, conventional Euclidean space, 3-dimensional, to the evolution in time, the time evolution, in a computer you see the seashell, the form and crack. The solution that he found multiplied the 3 axes by 2, so each axis had 2 values. That's the idea. However, with the unit, which is also 2 valued, you recover at the abstract level the 3-dimensionality that we need because we see the seashell in 3 dimensions. Yet, the complexity of the mathematics to represent the evolution of this seashell is beyond comprehension. So Thomas, I am on your side. I cannot understand. It does, at least gives us some next step out of the future. Thank you, Thomas.
I think that from history, right now the quantum mechanics is somehow simplify the problem. Okay? In the quantum mechanics, right now only have potential and kinetic energy. Actually, in the early time, the Hamiltonian and the Lagrangian building their theory, there are third terms, non-potential terms include. This kind of frame, until 1950, still used by theoretical physics. Then, make things simple. Why that term take out? Because I think mathematics quantum mechanics is easy because it's a unitary operation. So everything is linear and unitary is U diagonal unit to 1. So make all things mathematically simple. But if you use this, you can explain a lot of physics phenomena, but still have a lot of physics phenomena cannot be used, cannot be explained. So I think that the theoretical physicists make things simple, not experimental physicists make things simple. So right now, I think the Santilli theory will take a non-unitary operator back to the theoretical frame, so we can explain more and more things, not simply limited by reason and quantum mechanics.
Thank you, Professor McHighway. Allow me an illustration of your point. You saw the valence coupling. We need, as physicists, you see, for me, valence in quantum chemistry is a nomenclature. Show me the equation, attraction doesn't exist in quantum chemistry. So what we did, we produced the equation, it is attract. The message from mathematician is that to achieve that attractive force, there was one way, at least one way only, lift quantum chemistry, the axiom, the Hilbert space, and so on, under a non-unitary transform. Those forces that apparently are attractive are strictly non-Hamiltonian. They are beyond the Hamiltonian. Being non-Hamiltonian, the time evolution is non-unitary necessarily. It's the same for many, many, many cases. Now it's established beyond doubt, experimentally now. So that's the message of atomic mechanics as a non-unitary covering of quantum mechanics at various levels. Thank you. Thank you. Yes.
Athanasios Nassikas, and I would like to thank you very much for mentioning me as a contributor. I would like to ask you two questions related to all this very rich tool, which is very useful for the exploration of the universe in physics. The first question is, what is your opinion about Higgs boson? I have here you that you mentioned the Higgs boson. What they have found? It was Higgs boson, something else, I believe something else, but I would like to hear from you. And the second question is it possible the ISO normalization to lead to a kind of self-normalization?
Let me address the first question, Professor Nassikas. It's a very, very serious question, and indeed it has you see well, let me go to the last. Sorry, we can do it quickly here. Here is the accelerator on the left, and here is the scattering on the right. Now, during the acceleration, the validity of Einstein's special relativity is beyond doubt. It's proven that the machine works because it's based on relativistic quantum mechanics. So the validity of relativistic quantum mechanics, Einstein, is beyond any doubt. Let's not even talk about it. After clarifying that to prevent misrepresentation, let's look at when the proton leaves the acceleration, hits a nucleus, and produces this irreversible process. Ladies and gentlemen, at that moment, the claim that Einstein's special relativity and quantum mechanics are exactly valid is politics, pure politics. And so we are talking about all the numbers that are extracted at CERN, in my opinion, are poor, with all due respect, but in my opinion, we are in the land of democracy. You are Greek, Professor Nissak. So I can say this here. I cannot say this in Harvard and MIT. They will cut my... Okay, in my opinion, the numbers that extract at CERN, they are experimental beliefs. Why? Because they are based on the tacit assumption that relativistic scattering theory, relativistic scattering based on Einstein axiom, are exactly valid for a profoundly irreversible process such as this one. This is an assumption. If you assume relativistic scattering theory, you predict, this is my graduate students have done this, you predict the fusion of two nuclei into a third. Yes, you predict that, but this is an irreversible process. And you look at the calculation, look at the amplitude, it's independent of time. So you predict exactly, then you predict that the synthesized nucleus spontaneously decomposes in the original one, because the theory does not out of time, in violation of causality. Now, at MIT, graduate school, Berkeley, Université de Paris, anywhere, London, Imperial College, they don't say, they know it because I told them. They don't say, they don't show this time reversal image. But conclusion, the moment you build, and this is the contribution of this covering of the scattering that includes at least a first. We don't claim to be the last, but at least we have included a contribution from irreversibility that you cannot get out, eliminate, because you cannot reduce to point. Remains, even at the point level remains. And when you do that, then the Higgs boson cannot exist. There is no possibility, the existence is precluded. The second question, I appreciate if you're a very complex question, I appreciate if you can elaborate it a little bit, because I know that you are a very deep thinker. And
the second question is if ISO normalization
yes,
can lead to a kind of self.
Yes, I understood the words, but what do you mean with self
normalization means that always is normalized. We don't need any normalization. It's by itself normalized.
Okay, now I understand. Yes, because the answer is yes. Because we, you see, the normalization, historical, was introduced because of the divergence in quantum mechanics. And the divergence in quantum mechanics, they go back to the mathematics, local differential, one point. Being point, the delta function is a distribution, is a singularity at that point. Divergences are unavoidable. So, however, the moment you abandon this, they say, no, this is magnificent for lots of system, atomic structure, particle in accelerator. They have historical application in which they are exact, but they're not universal. When you say, no, there are systems that require extension, the moment you admit an extension, then you do achieve that automatically self-normalization, because you don't need, there is no infinity to remove. Our power series expansion can be truncated at the second term at best. We don't even need a third, because they're strongly convergent. So yes, the answer is a very deep intuition that you have, Professor Nassir, very, very deep. Thank you.
Any questions, comments? The last questions?
No, sorry, I was going to interrupt online. There's another session starting 5 minutes.
Okay, good enough, thank you. No, it's perfectly okay. Thank you.